Hello and welcome to Maths with El Profelo. This video we're going to be talking a little bit about some pre-calculus word problems that really have a background in algebra. Okay, so in this particular problem we're told that the concentration C of a certain drug in a patient's bloodstream T minutes after injection is given by, right, there should be an apostrophe right there. Right, it's given by this the concentration as a function of time is equal to 50t divided by the quantity t squared plus 25. Right, we're told to use technology to sketch a graph of the function, clearly identify clear features, and hence determine the maximum concentration of the drug and the time after injection at which this occurs. Okay. So the idea that this is t minutes after injection, we could say that, right, t is going to have to be greater than or equal to 0, right? So let's go ahead and use our technology. We're going to use ti right over here for now. Okay, so let me slide this up where we can see a little bit more. Okay, so what we'll do is we'll come over here to y equals, okay, and I'm going to hit the alpha, the green key, and y equals, and that's going to give me a fraction format, and I'm going to have 50 times my variable squared plus 25, right? So I can plot my function, and I can go zoom 6 is my standard, so I'll press zoom 6, and so I'm going to get my function. Right, so I can see a little bit of what the function looks like here. Let's adjust that brightness a little bit so you can see a little bit better. But really and truly, right, note that we're saying that it's after injection, so the time really we only care about the positive piece. So I'm going to adjust my window, right, and let's come over here to adjust my window, and my x minimum I'm going to say is, we'll put it at -1, right? Then we have the x maximum, and we'll still be able to come over here and look at our graph, right, and make sure that we can see the key features of the graph. And it looks like we might need to adjust a little bit more, so I'll come back to my window, right? My y minimum, I might set that to -1 because I don't seem to have a negative concentration in the blood. All right, my y maximum, I'm going to decrease that down to 5, right? And my x maximum, I'm going to increase the x maximum up to 50, right? And just to kind of see what our graph looks like. So now I can more clearly see the shape of my graph and what it's doing, right? I do seem to have this maximum up around 5, right? So I might change this y max even further and go y max up to 8, and maybe I change my x maximum to 100 and x scale to 10 to be able to see even more of my graph and exactly what's happening with the concentration of this drug. Okay, so we want to go ahead and draw that sketch. All right, so I'm going to put this to the side so I can draw the sketch of my graph, and a good sketch always involves having nice axes, right? And so I can see kind of the general shape of my graph, right? Comes up, goes down, right? And I seem to have this asymptotic behavior going down, right? Now I am asked to figure out and determine what the coordinates are of that maximum, right? And so I'll go ahead and find those coordinates, and in order to do that I can go second trace. I want to find the maximum, right? I know that the maximum left bound, right, to the left of that, if I look clearly 0 is to the left, and a right bound, let's see here, each of my tick marks I believe is 10, so my right bound, right, I could also arrow over. And I could come over here and say, well, that's clearly to the right. Press enter. All right, now I'm going to guess, and it gives me my maximum, and that maximum, right, is at the point 5, comma 5, right? So what does that tell me? This tells me that the maximum concentration occurs at 5 minutes after injection and has a concentration value of 5. Right? Now, this concentration value of 5, we might say, right, we don't necessarily know what the units are, right? It's 5 what units? We're not sure. It doesn't provide that in the problem. But this is what we have for our solution. Okay? It is important to note that we could talk about the end behavior, and that as t approaches infinity, right, the concentration of the drug approaches 0, right? And that is because the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator for this rational function. So I know then that my end behavior, as t goes to infinity, right, my function is going towards 0, which lets us know that eventually the concentration of the drug in the bloodstream is gonna go. Okay. So this has been Maths with El Profilo. We'll have a few more videos coming up. Thank you for your time.